Today we shall discuss about a new topic, engineering and specialty polymers. There are different categories of polymers, polymer materials from which products are made. We are very much acquainted with the commodity polymers or general purpose polymers, which find high volume application, high volume consumption, and which are cheaper as compared to the other engineering and specialty polymers. Not only that, these general purpose commodity polymers are used for general purpose use, that means where no special need for high temperature resistance or resistance to harsh environments, chemicals and solvents. These are called general purpose polymers, whereas engineering and specialty polymers are known as high performance polymers, which are supposed to function at elevated temperature, and they are supposed to have excellent solvent resistance, chemical resistance, and they can withstand harsh environments of temperature and gases. Not only that, their mechanical properties are quite high as compared to the general purpose polymers. Now, what are engineering plastics or engineering polymers? The polymers which are used for the manufacture of premium plastic products or polymeric products having high temperature resistance, they must have high impact strength, they must have high resistance to chemicals and solvents, or they should provide other special properties like flame retardancy or fire retardancy or high abrasion resistance, or they must they must be resistant to extreme temperature environments, including say cryogenic temperatures, etc., etc. To speak about the examples, we can tell the names of polyamides, say nylons. Nylons may be of two types, aliphatic nylons or aromatic nylons. Then ABS resins, acrylonitrile, butadiene, styrene resins, or acetal resins, polycarbonates, polysulfones, polyphenylene oxide, polyparaphenylene sulfide, fluoropolymers or fluoroplastics, photo resistant polymers, so and so. Now, let us start with the discussion on polyamides. Polyamides exhibit excellent resistance to wear and abrasion. They show very low coefficient of friction. They provide good resilience and high impact strength. Fibers can be made from such polymers, particularly say polyamides. For example, Nomex, I have told in other lectures, this Nomex is one aromatic polyamide, and Kevlar. This is also aromatic polyamide, only the linkage in the phenyl ring of the amine part differs. Say one is ortho linkage and the other is meta linkage and the other is para linkage. Such aromatic polyamides as compared to aliphatic polyamides offer outstanding resistance to high temperature, and they offer very high tensile strength for use as fire retardant fabric. Say not only that fire retardant fabric, that can be useful as protective armor or vests, which is resistant to bullet piercing, that means bulletproof jackets or bulletproof armors can be made from such high performance aromatic polyamides. Not only that, for some heavy duty automobile tires, the cord used in the tire, that is also made of this aramid fiber or Kevlar fiber, aromatic polyamide fiber, which actually replaces sometimes steel fiber or polyester fibers. Now, out of these aliphatic polyamides, we know about nylon 6 and nylon 66, and aromatic polyamides I have already mentioned, these are known as aramids, and these aramids can be Kevlar, either Kevlar or Nomex. Now, let us look into structures of chemical formula and their structures of some important polyamide. So, nylon 6, this nylon 6 is a fiber grade polymer which is made from caprolactam. It is a ring compound. This ring compound can be polymerized to nylon 6 by ring opening polymerization. Its formula is NHCO CH2 whole 5. This is the repeat unit of the nylon 6 polymer. For preparing nylon 6,6, this caprolactam is not suitable. Here hexamethylene diamine as the amine part and adipic acid as the acid part are condensed through nylon salt formation to produce nylon 6,6 polymer by melt polycondensation at high temperature, say around 265 to 270 degrees Celsius. Here this nomenclature nylon 6,6, that numerical figures 6 and 6 comes from the number of carbon atoms in the amine part and the number of carbon atoms in the acid part. Here in the amine part 6 methylene units are there. In each methylene unit there is one carbon, and in acid part there are 4 methylene units. Each methylene unit contains one carbon and 2 carbons are present in the acid groups. So, this way it forms the nylon 6,6 and it is actually this nomenclature is given as nylon 6,6. Similarly, one can have nylon 6,10. In this case 6,10, same diamine hexamethylene diamine HMDA is used, and in the acid part instead of adipic acid the sebacic acid is used, which contains 8 methylene units and 2 carboxyl group. So, this way we get nylon 6,10. As I mentioned the name of Nomex, which is aromatic polyamide. Basically such aliphatic or aromatic polyamides both contain amide linkage, the CONH. The CONH is the amide linkage, CONH is the amide linkage. If this kind of linkage is present in a polymer, that we call as polyamide. Now, if this linkage is connected to aliphatic units, we call it aliphatic polyamide, and if it is linked to some aromatic groups, aromatic rings, phenyl rings, etc., we call it aromatic polyamide. In case of Nomex, as I just told, that Nomex contains this phenylene diamine, and these amine groups are linked at the meta position or 1,3 position, as well as this isothallyl chloride. This is made from isothallyl chloride or isothalic acid. It is isothallyl chloride is more reactive to isothalic acid. So, isothallyl chloride is used for condensing with this metaphenylene diamine, and it forms this amide linkage and it forms this aromatic polyamide Nomex. Now, terethalloyl chloride and paraphenyl diamine, terethalloyl chloride in place of isothallyl chloride. Here in case of isothallyl chloride it was the meta linkage, whereas in case of isothallyl chloride is the meta linkage, in case of terephthallyl chloride it is para linkage. So, this linkage or meta linkage or para linkage or meta linkage, that causes large change in their structure as well as in their properties. So, this is also a fiber grade. Sometimes this is used for making film, Nomex is used for making film, whereas Kevlar is always used for fiber, which is made from para linkage of diamines and the diacid or diacid chlorides. So, this is terephthallyl chloride is the diacid chloride and paraphenylene diamine is the diamine. Now, these are aromatic polyamides, say Nomex is synthesized by reacting metaphenylene diamine. This is the formula of metaphenylene diamine, this is the formula of isothallyl chloride. So, they react to form this polymetaphenylene isothalamide or Nomex. This is the structure or formula of this Nomex or polymetaphenylene isothalamide. Now, this Nomex is is resistant to heat at high temperature, thermal resistance, thermal stability is very good, but it decomposes or starts decomposition at about 370 degree Celsius. So, this polymer can be safely used up to say 200 degree, 150 or 200 degree environment without any decomposition or without any loss in their strength properties. Now, this is linear aromatic polyamide Kevlar, on the contrary, decomposes above 500 degree Celsius. Just to compare their decomposition temperature or thermal stability, taking this decomposition temperature, having the meta linkage, this Nomex starts decomposition at 370 degree, whereas the aromatic polyamide Kevlar starts decomposition above 500 degree Celsius. This is due to the molecular alignment, molecular organization. If you go back to the previous slide, here you see the molecular symmetry is more than that is found in Nomex due to the presence of this meta linkage. So, the thermal stability is obvious from the configuration of the polymer molecules or the linkage of the amine and acid parts at the meta position for Nomex, at the para position for the Kevlar. Now, this Kevlar polymer is used as substitute for steel, as I mentioned, this is used as substitute for steel in belted radial tires, automobile radial tires and bulletproof vests. This is that is why this is called a high performance specialty polymer. So, this all about I have told about the aromatic polyamides or aromatic nylons and aliphatic nylons, you know, and polycarbonate. Next polymer is polycarbonate. Polycarbonate. Now, carbonate means it contains CO3 group. This carbonate group is present in the polymer along with the phenyl rings. Now, this basically the general polycarbonate is made from bisphenol A. This is the formula of bisphenol A. This is a phenolic group, two phenolic groups is present in this bisphenol A, and this is the phosgene COCl2. Now, this bisphenol A is highly reactive to phosgene, or phosgene is highly reactive to bisphenol A. After reacting, they form a polymer that is known as polycarbonate. Here you see this carbonate linkage COO, this carbonate linkage, this on both side of this carbon 2 oxygen atom is there, one is here and one is here. This is the way how to show the repeat unit of this polycarbonate. Now, this polycarbonate is an amorphous polymer having very attractive engineering properties, including high impact strength, high heat deflection temperature, they have low moisture absorption, low combustibility, good dimensional stability and high light transmittance. Now, this polycarbonate is an engineering plastic. This because of the presence of such phenyl ring in the polymer chain and high and polarity due to the presence of oxygen linkage, CO carbonate linkage, this carbonate linkage carbonate functional group in the polymer chain, this group, this is polar and the presence of this phenyl rings, that makes so strong. Impact property is also very good, and heat distortion temperature means at heat distortion temperature tells about the dimensional stability of the product at elevated temperature or under pressure, under load. So, it should not be deformed at high temperature. So, here the temperature it can withstand up to say 130 degree Celsius without any deformation or without any deflection or distortion. And by virtue of the presence of these phenyl rings, although the carbonate group is present over there, it shows excellent moisture resistance characteristics, moisture absorption characteristics. It does not allow moisture to penetrate in the bulk of the product made of polycarbonate. And because of the presence of these phenyl rings, although methyl groups are there, phenyl ring and the CO3 groups, it shows excellent resistance to combustibility, or one can say it is a fire retardant or flame retardant polymer. Not only that, it has a good light transmittance, light transmission property. Say it can transmit UV light up, visible light up to 88%. That is why this polycarbonate is used as automobile headlights covers, as well as window glass, or since it can withstand very high temperature, it can be used as baby feeding bottle, which is sterilizable at autoclave temperature, so and so. Now, this is to talk about the application used as this polycarbonate can be used as high impact resistant substitute for window glass. Problems of limited scratch resistance of polycarbonate. Now, this polycarbonate has one limitation or one problem with this, scratch resistance is not good. Not only that, this polycarbonate starts yellowing when it is exposed to UV light. If there is high percentage of UV light in the sunlight, there are certain regions where UV percentage is more. So, in that area this polycarbonate starts yellowing, that means yellow color is developed in the polymer, although its transmission property is good. Now, this can be managed by some coating of silicone polymer, as well as coating with that coating may contain some free radical stabilizer. So, silicone free radical generating compounds in silicone, that composition can be used as a coating over polycarbonate items, which will release free radical on exposure to UV light, and that stabilizes the decomposition of polycarbonate to develop such yellow color. Now, there can be other polycarbonates as derivatives, say bisphenol A derivatives. Some groups can be functional groups can be attached to the phenyl ring of bisphenol A, and the product will be polycarbonate, but that is different from that normal bisphenol A polycarbonate. So, such type of polycarbonates can be prepared by interfacial polycondensation or by melt transesterification of tetrasubstituted bisphenols. As you have seen in this case, if there are functional groups attached at this linkage at this point, at these 2 points here, as well as at this point, that means I mean to say here is one functional group, here is one functional group X, 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 X. So, such type of bisphenol A can be interfacially polymerized polycondensation reaction, interfacial polycondensation reaction can be converted to this is 1, 2, 3, 4 tetra substituted bisphenols and bisphenol polycarbonate that undergo some transesterification reaction. So, here X might be some halogen groups, halogen atoms, say it can be in major cases it is bromine, or sometimes it can be even methyl group. So, your polycarbonates can be of different grades depending on the presence or absence of substitution on the phenyl ring of the bisphenol A component. We can have different grades of polycarbonate. Now, let us see other polymer. Let us pass on to other polymers from polycarbonate. Say polyphenylene oxide, this is another specialty polymer or high performance polymer. Polyphenylene oxide. Polyphenylene oxide means that it contains phenyl ring as well as oxygen. So, that is known as polyphenylene oxide. The formula of one polyphenylene oxide is this phenyl ring and oxygen. That means, this is the repeat unit, this can be repeated along the backbone chain. So, basically one can say this is a polyether type of polymer, and oxygen is linked to phenyl rings. So, this phenyl ring adds to the rigidity of the polymer molecule, and due to the presence of such rigid phenyl ring, it shows high performance characteristics like high thermal stability as well as other good mechanical properties, and due to the para linkage the tensile or mechanical properties would be better. So, the name of this polymer is poly 2,6-dimethyl 1,4-phenylene oxide. It is prepared by reaction of 2,6-xylenol, this is 2,6-xylenol with oxidative coupling polymerization of 2,6-xylenol in presence of copper amine as catalyst. This polymer is formed. Now, while this polymer is formed, this polyphenylene oxide PPO is produced. Along with this, some byproduct 3 prime 5 prime tetramethyl diphenylquinone DPQ. So, this tetramethyl diphenylquinone is formed as a byproduct along with this main PPO. It should be removed, or the product should be purified by removing this DPQ from the main product. Now, this polyphenylene oxide shows higher heat distortion temperature than that of polycarbonate. So, here is a difference between polyphenylene oxide and polycarbonate. This polycarbonate contains one carbonate group after a phenyl ring, but here it is only oxygen, and because of the distance between the two phenyl rings, that means the only one oxygen atom is present between two phenyl rings, the rigidity of the polymer is high. That is why the heat distortion temperature is higher than that of polycarbonate. But although the heat dissipation temperature is high, but such type of polymers, this polyphenylene oxide, is difficult to melt process because the melting temperature is high and they have very high glass transition temperature Tg. So, in order to overcome such difficulty of melt processing, because processability is another criteria, a polymer can have high performance characteristics, it can be very strong, it can be very stable at elevated temperature, but it should be converted to a product. That means, it should be compounded with additives, then it should be fabricated or shaped with the help of using machineries like compression molding or transfer molding or even extrusion or injection molding, all these things, but those actually involve this melt processing of the polymer. That means, the polymer should melt at high temperature and it should lower the viscosity by melting, and then it should be should have adequate flow characteristics, rheological characteristics, then only it can be formed to give the required shape and dimension of the product. Since PPO is lacking in this property, it is blended with another polymer, auxiliary polymer, that is high impact polystyrene. High impact polystyrene has good impact resistance property, but it melts at lower temperature than PPO. If a certain proportion of high impact polystyrene is blended with polyphenylene oxide, that blend can be easily processed, and that blend is available in the market as a commercial commercial product. Brand name is Noryl. This Noryl, this polyphenylene oxide high impact polystyrene blend Noryl is strong, as well as it shows some flame retardancy properties because of the presence of large number of phenyl rings along the backbone chain. So, flame retardant polymer blend composition with high performance properties like thermal resistance etc. Can be prepared by blending high impact polystyrene with polyphenylene oxide, and that polymer is suitable for electrical as well as automotive applications. Next, let us see acetyl resin. This is a kind of premier resin, we can say. It was commercialized, and somebody has detected this presence of acetyl resin in Halley's comet. In Halley's comet, this acetyl resin is there, acetyl polymer is there. Basically, this acetyl resin is called polymethylene oxide or polyoxymethylene CH2O. It is actually a polymer of formaldehyde or trioxane. The formaldehyde, you know, is the formula of formaldehyde is very simple, HCHO. Now, it can be polymerized to form polymethylene oxide, and it can also be prepared from trioxane. Two different routes are there, formaldehyde route or the trioxane route for the synthesis of polyoxymethylene. Now, this polyoxymethylene is stabilized against UV degradation by UV absorber and hindered amine light stabilizers. So, if hindered amine light stabilizer is blended with this polyoxymethylene or other UV absorbing compound as additive, then this polyoxymethylene is excellent composition. Polyoxymethylene with UV absorber is an excellent composition which can prevent the product from degradation from UV exposure. Now, there is a change of color due to the exposure to visible light or the sunlight, that happens due to UV absorption, and as a result on absorption of UV it degrades and with an attendant loss of tensile strength as well as toughness also is reduced due to the UV absorption. So, UV absorbing compounds or UV stabilizer or hindered amine type of compound. Hindered amine means amine derivative with long hydrocarbon chain, that such type, that is known as HALS, hindered amine light stabilizer, can reduce the degradation of such polyoxymethylene from UV light. Sometimes it has been found that carbon black is a very good UV absorber as well as titanium dioxide filler. So, carbon black, a minute quantity of carbon black as well as titanium dioxide, if they are blended or mixed or compounded with this polyoxymethylene, that becomes highly effective for UV screening. UV, that this titanium dioxide or carbon black will absorb the UV and it will prevent, it will protect the polymer from the degradation. Due to the, if this UV can be UV absorption or UV protection from UV can be done, then it is an excellent polymer, because it shows very high dimensional stability, because although there is no aromatic linkage present over here, but it shows very high dimensional stability, and sometimes their tensile strength and impact tensile strength and modulus and impact resistance is so high, impact property is so high, that such acetal resin with when filled with carbon black and titanium dioxide can replace sometimes metals in gears. That means, this polyacetal gears can be used in place of metals, or some machine parts can also be made in place of steel. So, this polyoxymethylene is a very good polymer for mechanical or engineering application like gears and machine parts. Next is polysulfone. We have seen polyphenylene oxide, we have seen polyamides, aromatic polyamides, we have seen polyphenylene oxide, we have seen polycarbonates, we have seen acetal resins. Now, let us see polysulfones. This polysulfone is again another engineering polymer. Polysulfone means it contains sulfur in the polymer. Just look at the formula of this polysulfone. Here, this due to the presence of this sulfur with 2 oxygen, this is a sulfone group, this is the SO2 sulfone group. Now, this sulfone group containing reactant can be used, that is this is a polymer containing sulfone group having 2 phenyl rings at the both side of the sulfone group, and this is bisphenol A. This is bisphenol A. So, bisphenol A and this monomer can be used for making polysulfone. This polysulfone is commercially available with the brand name, trade name Udel or Ultrason, Udel or Ultrason. Similarly, we can have polyether sulfone. Polyether sulfone, this polyether sulfone, say Ultrason ETM or Victrex TM. So, this contains only this type of formula or linkage having phenyl rings and sulfone group. Just here one thing to be noted between, if you compare this polymer with this polymer, between 2 sulfone functional group there are many phenyl rings. Here 3-4 phenyl rings are there. Here after 2 phenyl rings 1 sulfone group is coming along with the presence of this ether linkage. This is the ether linkage through linkage through oxygen. There is another polysulfone, this is called polyphenyl sulfone, Radel R, Radel R. So, this is the formula of polyphenyl sulfone. Now, let us look into a comparative situation of these comparative properties of different polysulfones. One is PSF, one is PES, and another is PPS. This PSF is polysulfone and PES is polyether sulfone and PPS is polyphenyl sulfone. So, polysulfone, polyether sulfone, polyphenyl polyphenyl sulfone. So, in these three polymers, number of phenyl rings as well as the number of oxygen linkage, ethyl linkage in their in the repeat unit of the polymer differs. And let us see their change in properties. Look at the specific gravity. Specific gravity varies from 1.25 to 1.37. Tensile strength, in the case of this polyether sulfone, tensile strength is highest among these three. This is 84 megapascal, and tensile modulus, obviously tensile modulus is also highest for this polyether sulfone, and elongation at break is at the lower range for this polyether sulfone. Flexural strength is excellent, 129 as compared to 106 and 85.5 for PSF and PPS respectively. And flexural modulus, again it is high. Then impact strength, it is the impact strength, it is here it is something wrong, it will be 64.1 instead of 641, it is 64.1 not 641, and it is 85 highest impact strength for this polyether sulfone. And heat distortion temperature is almost comparable for these two, polyether sulfone and polyphenyl sulfone, and it is lowest for this polysulfone only. Now, we can have this different types of sulfone as I told. Now, let us look into one kind of sulfone, that is bisphenol A sulfone containing bisphenol A in the polysulfone moiety or in the repeat unit. Now, that is prepared or synthesized by reacting sodium bisphenolate, sodium ion of bisphenol, sodium salt of bisphenol known as sodium bisphenolate. So, this is reacted with sodium hydroxide, bisphenol A is reacted with sodium hydroxide to form this sodium bisphenolate. Now, that is reacted with dichloro diphenyl sulfone. This dichloro diphenyl sulfone that condenses through this chlorine atom of this dichloro diphenyl sulfone, and some sodium chloride molecule is eliminated out, and by such elimination this linkage occurs at this oxygen, this phenyl ring and this phenyl in phenyl ring gets linked through this oxygen and to form this bisphenol A polysulfone. And in this step, since HCl is there, some acid is used, so HCl is produced over here. Okay. Polyether sulfone can be prepared from by the reaction of field cap reaction of sulfonyl chloride. Now, it is synthesized by electrophilic substitution through field cap reaction. This is the Lewis acid catalyst, ferric chloride. This is used for condensing this sulfonyl chloride, and such polysulfone is widely used in the automotive industry for different automotive parts, because it shows very excellent high temperature resistance and excellent mechanical properties, as well as it is also used in the aerospace in the aircraft or aerospace structures, and this is also used in medical industries like some biomedical components are prepared or used biomedical components are made from this polyether sulfone. Say for example, this is quartz iodine headlamp reflectors for cars, sterilizable medical devices and overhead passenger service modules on aircraft. Polyphenylene sulfide can be synthesized by reacting para dichlorobenzene with sodium sulfide. Sodium sulfide condense with this polymer with this para dichlorobenzene monomer and form polyparaphenylene sulfide. This polyparaphenylene sulfide PPS possesses outstanding chemical resistance. Although sulfur is present over here, it is resistant to very corrosive chemicals, reactive chemicals. So, resistant to chemicals and shows good electrical properties, excellent flame retardancy characteristics, low coefficient of friction and high transparency to microwave radiation. And this is due to this or flame resistance properties or flame retardancy properties comes from the less amount of hydrogen present in the polymer. Here the formula of the polymer, empirical formula will be polymer would be say 6 carbons and only 4 hydrogens and 1 sulfur. There is no more hydrogen or oxygen, these are present. So, this polymer is not combustible since amount of hydrogen is less there, it forms char. Char formation occurs on at the flame temperature or when it comes in contact with flame, or if there is any fire, if this polymer is present, that forms charring effect. So, this fire retardancy effect is observed in case of polyphenylene sulfide. This, so far as the processability or fabrication of this polymer is concerned, this polyphenylene sulfide can be melted at 300 to around 300 degrees Celsius temperature, and it can be injection molded in this in the range of 300 to 370 degrees Celsius temperature. Major applications of this polyphenylene sulfide include cookware, different types of cooking ware can be made from this polyphenylene sulfide. We are acquainted with some cookware, cooking wares, that is Teflon coated metallic cookwares, but this polymer can be directly used for making that cookware since that it can withstand very high temperature. Apart from cookware, this polymer is used in mechanical parts, say bearings or gears, mechanical gears or mechanical bearings, and some pump parts or some these pump parts can be made from this polymer for service in various corrosive environments. So, in pumping of corrosive chemicals, corrosive liquids, the seals and gaskets or bearings in the pipeline or the propeller of the pump, those are actually made of this polyphenylene sulfide polymer. Now, let us look into the polyester. Now, what is polyester? This polyester is ester group is formed by the reaction of some alcohol group with some acid group. So, this acid group and alcohol group condense to form an ester. This is the ester functionality, COO ester functional group. This is an ester. This is a simple low molecular weight ester. It is not a polymer. Now, this principle of esterification has been extended to synthesize polyester by reacting a diol having two alcohol groups with a diacid. Here also this condensation occurs between this acid and alcohol to form this ester linkage. This is the repeat unit, this is the ester. Now, this R and R prime can be either aliphatic or aromatic. Depending on the nature of R groups, we get aliphatic polyester. If it is aromatic, R and R prime is aromatic, we get aromatic polyester. Now, one well known polyester is PET, polyethylene terephthalate. There can be another polyester, polybutylene terephthalate. Now, this alcohol part can be ethylene glycol or butylene glycol Bg. If this ethylene glycol is condensed with terephthalic acid Ta, terephthalic acid, we get PET, and if this butylene glycol is condensed with terephthalic acid, we get polybutylene glycol PBT. But the properties of these two different polyesters are not same. You just have a look into the formula of this polyester. This polybutylene glycol is condensed with terephthalic acid to form this PBT. This is the PBT formula, and if there is 2 methylene units, it will be PBT. Now, PBT is supposed to be more flexible. PBT is supposed to be, this polymer is supposed to be more flexible than polyethylene terephthalate. Polyethylene terephthalate can be available in the form of film, it can be available in the form of fiber, it can be used for making molded plastic products. Say beverage bottles or drinking water bottles are made of PET polymer, polyethylene terephthalate polymer. But PBT is flexible. Now, let us look into their properties correlating with their formula and structure. Both PET and PBT are moisture sensitive because of the presence of this ester linkage, but they possess high strength. they are rigid due to the presence of phenyl ring, and this polymer becomes tough. Toughness property is good because of the presence of this methylene units, which is flexible. Flexibility is offered by these methylene rings and rigidity is offered by this phenyl ring. So, this flexibility and rigidity are compromised or adjusted in such a way, so that one can achieve very high strength as well as high toughness, and they show excellent dimensional stability, low coefficient of friction, and they show resistance to abrasion, mechanical abrasion, as well as a good resistance to chemicals and grease. Now, synthetic garments, fabrics, majority of the today's synthetic garments are made from this PET fiber, polyethylene fiber, PET polyester, polyethylene terephthalate fiber, that is synthetic polyester, and that is also blended or mixed with sometimes cotton. So, cotton polyester blended fabric is available in the market, and we are basically very using such type of garments. Principal applications of PBT is that can produce injection molded parts for application in the field of electrical and electronic gadgets, as well as for automotive parts. So, there can be a competition between PET and PBT. Now, one can have purely aliphatic polyester, this ethylene glycol or butylene glycol. Here it is condensed with aromatic diacid, that is terephthalic acid. Now, this can also be made from isophthalic acid. Now, if we replace this terephthalic acid with isophthalic acid having linkage at the meta position, we get a polymer, but that will not be fiber grade polymer, that can be used for making some molded plastic items. Apart from that, this acid part can also be replaced with aliphatic, this aromatic acid part can be replaced by aliphatic diester, that is say adipic acid. Adipic acid is four methylene units are linked to 2 carboxyl groups. This is adipic acid. So, in place of this phenyl ring, 4 methylene units have come, and we can get this polymer if we react with ethylene glycol. So, it will form a polyester having this ester linkage COO. This HOH will go out as minus H2O, and we will get a polymer This is the repeat unit of aliphatic, purely aliphatic polyester condensed with adipic acid and ethylene glycol. Now, its property is much inferior to that of either PET or PBT, but it can also be used as a fiber grade polymer. It will be highly flexible, but its strength will be inferior to that of polyethylene terephthalate or polybutylene terephthalate. Thank you.